So in this part of the O-level AdMath series, we're going to be talking about logs, which are a different way of representing exponential equations. Exponential equations basically include those in which a base has a power and that's equal to something or something. Like for example, 2 to the power of 3 being equal to 8, this is an exponential equation. However, it can be represented using logs, which basically make things simpler. So let's see how to represent an exponential equation using logs. So basically in a log, what you do is write it as such, where the log is written first to a certain base and then an argument is put inside of it, and that leads to an output or an answer, which is basically the exponent. So I'm going to explain how this works in just a second. As we use this example of 2 to the power 3 being equal to 8, the base is basically 2 in this case, meaning the thing that is being put to a certain power is the base in our case, and the argument is the answer that basically comes. So in this case, we basically represent it as log 2 of 8 being equal to 3. So the base is the thing that is being put to a certain power. The number 8 or the argument is basically the thing that is the output, and 3 meaning the exponent is the power that we are putting the base to. So it would be log 2 of 8 is equal to 3. So I'm going to give you 3 equations and I want you to convert them into the opposite form. Log form to exponent and exponent form to log. So in this case, we see that 5 is written at the bottom of log, that means it's the base, and x is written as the answer, that means it's the exponent, and the argument is written in the middle, which is 25, so the answer must be 25. Now in this case, we see that 6 is the base here because it's being set to a certain power, so it's going to become log base 6, and the argument that we're going to pass is the answer here, which is 216, and the answer will be the exponent that we are putting 6 to, which is 3. In this case, we see 7 being the base here, so 7 is going to be the thing that's going to be put to a power, and the power is going to be x in this case because the answer is x in the log, and then 49 is going to be the answer because 49 is the argument here. So now we have figured out how to convert from log form to exponential form. Now let's talk about how we read this form. So basically log 7 or log 6 of 216 would be read as log to the base of 6 of 216 is 3. So that's how we read log form in this case. But the main question comes, why do we have to use logs? Why can't we just use exponential forms? Well, the reason for this is that it helps simplify many algebraic expressions and make them easier for us to solve. In cases where we don't know the exponents, for example, in this equation, where we can write something like this equation, it would make it easier to use logs to find the values of the powers that we don't know. Well, let's talk about some principles of logs. Log to the base of a being b equals to x basically means that a to the power of x equals b, because a is the base, x is the power, and b is the argument that is being put. Thus, this is the way you can represent and change exponential and logarithm form into one to each other. The second thing is that logs to the base of a being equal to 1 are always equal to 0. Why? Because when you put any number to the power of 0, you basically get 1. And when you rearrange this into exponential form, you get this form, that a to the power of 0 basically equals to 1. So we know that in Dice's rule from before, right? That's basically what it is written in another form. Now let's talk about another principle, what we call logs to the base of 10. Well, you see, there are certain logs that are used very often, and one of them is log to the base of 10. Log to the base of 10 being equal to a is basically equal to log a or LGA. That's another short form of what it is usually called. Instead of saying log to the base of 10, you can just say LG of a. That's a common way of representing this because they're used so often. And another log that's used often is log to the base of e. In this case, e is basically like a constant. This constant basically has a value of 2.718 or is approximated as 2.72. Like pi has a value of 3.14159. This is also used for certain other values like finding exponents or natural increase or growth or decay. So in this case, when we take logs to the base of e, we basically call them ln of a, or we can call them the natural log. So since they're used often, we don't write log to the base of e, we just write ln of a. Now let's talk about certain restrictions that come along with logs, meaning what powers or values we can use in logs and what we can't. So if we take a value like log base a of b equal to x, b cannot be equal to a negative number. Because think about it, we could not put a positive number to any power that would make it negative. Even if we put a positive number like 2 to a power of negative, for example minus 2, it still becomes 1 upon 4. A to the power of minus infinity to infinity does not equal negative in any case if a is positive. We can see this with examples like 2 to the power of minus 3. In this case, 2 to the power minus 3 is basically equal to 1 upon 8, which is still positive, and the answer will always be positive if A is positive. And A cannot be negative in logs, meaning the base cannot be negative in logs. Why? Because it would make it hard to ascertain which log is leading to which answer. Because minus 2 square and 2 square are both 4, so in this case, we can say that they both would have the same answer. And thus we prefer to keep it one-dimensional in this case, where we always take the base to be positive. For a summary of all this lesson, basically logs are simply saying what power makes my base turn into my argument. So log 2 of 4 would be 2 because 2 power would make 2 turn into 4. And similarly, log 5 of 125 would be 3. Why? Because the power of 3 is needed to turn 5 into 125. So think about what makes the base turn into the argument, and that will be your answer. Secondly, let's talk about the second principle here, which is that the base must be positive and the argument must be positive. The third principle we have is that logs to the base of 10 are called LG or a log only without any base written to them. So log or LG would be called log to the base of 10, and log to the base of E are called LN or natural logs. So we can simply write them as that without expanding the full form and calling it log to the base of E. They are natural logs. Hope you like this video, and please check in for the next part. Goodbye.